Hello, Leiden Geometry students. In this assignment, we're going to talk about dilations. Now, the first thing you need to know about dilations is that everybody says it wrong. People tend to want to say the word dilation, which is not correct. The word is dilation. You just sound smarter when you say it the right way. So, dilation. All right, a dilation is when you take an object and you make it grow or shrink. For example, this triangle, we're going to make a larger triangle here. This is a dilation. We simply take an object and we make it bigger or smaller. These are all some simple examples of dilations. And in geometry, when we do this with our graph, it's going to look something like this. We're going to take a shape and we're going to recalculate its coordinates. Now, there is a little catch to it. It's not making it bigger or smaller any way you want. We have to do it and keep the proportions of the original shape. In other words, if I start with this picture of a weird looking wet cat alien thing, and I make it bigger, but I only make it bigger in one direction, in other words, we stretch it, this is not a dilation. A dilation has to keep the original proportions. In other words, if it gets twice as tall, it would also have to get twice as wide. So this picture is an example of a dilation. We took the original picture, we doubled both the height and the length of the shape. Before we get to doing this in a graph, we're going to talk about doing this by hand. Here we have a triangle in a graph, and the coordinates of the vertices of this triangle are not really all that important. What is important is the point that we're going to use to dilate it. Whenever we're making a dilation, we make a dilation from a point, and when we do it in a graph, at least in this class, we're going to do it from the origin, what would be the coordinate 0, 0. And the way we're going to do this is I'm going to take a ruler here, and I'm going to connect the origin to each of the 3 points that make up the vertices of this triangle. In other words, we're going to draw a line going from the origin through point C, and from the origin going through point A, and from the origin going through point B. So I have these lines coming out of the triangle, and if I wanted to make another triangle like this one, but let's say I want to make this triangle twice as big. Now, first off, with those extra lines, my triangle got a little bit crowded here. Let me color this thing in. Okay, I couldn't find my crayons, so its color is just black. All right, now let's say I want to take this triangle and I want to make a dilation of this triangle. I want to create one that is twice the size of this. What I would do is for each of these points, I would measure how far they are from the original point, the point of dilation over here. So if I'm going to do that with point C and I'm measuring in centimeters, point C is about 3.2 centimeters from our center of dilation. So what I'm going to do is I'm going to actually double that and go 6.4 centimeters from the center of dilation and create my new point here. This is going to be the new point C. And we're going to do that for each of these points. And here, the new point B, twice as far away, ends up still right in the middle of that triangle, so I had to clear out a little space for it. And point A looks to be about 3 centimeters away, so I'm going to double that and make the new point A 6 centimeters away. That will become our A prime. Next, all we have to do is connect the dots for A prime, B prime, and C prime, and we have created a triangle that is twice as large as the original. And now we've created a new triangle that's the same shape as the previous triangle, except it's twice as large. The length and the width and the height, they're all 2 times larger because we went 2 times the distance from the center of dilation. There are other ways to do this rather than graphing by hand. In fact, any graphing program this can easily be done on, or with a graph paper, even without the ruler. Here I have a triangle with coordinates A at 1, 2, B is at 3, 2, and C is at 3, 1. We can dilate it. We want to make a triangle that's 3 times larger, or we say the scale factor is 3. That's essentially what we're going to multiply by. So we're going to multiply all the coordinates by 3. So here if I take the coordinates of point A, 1, 2, if we multiply both those numbers by 3, it'll become 3, 6. This is our new A prime point. We do that with each of the points. 3, 2 times 3 becomes 9, 6 for B prime. And C at 3 comma 1 becomes 9 comma 3 at C prime. And then simply connect the dots to create our new triangle. The measurements of this new triangle are now twice of what they were in the original triangle. The original side over here on the right, this was 1. I'm sorry, I said twice as big. It's 3 times the size because we multiplied by 3. This side had a length of 1. Now it has a length of 3. This side on top had a length of 2. Now it's got a length of 6. This really is still doing the same thing as doing it with the ruler, because if we took this picture and connected the points A prime to A, B prime to B, and C prime to C, we'd still see the same picture that we had when we draw this by hand. The grid can also help us with the measurements of the sides. For example, it's easy to count out that the length of the sides of the little triangle, the what are called legs, are 2 and 1 units, and we can simply multiply those by 3 to get the lengths of the sides in the larger triangle. Now 2 times 3 to get 6, and 1 times 3 to get 3 for the lengths of the sides in the larger triangle. One of the nice things about these problems is the arithmetic is easy enough that you don't really even need the graph to talk about dilations. For example, if we started off with a triangle and we're told the coordinates, triangle ABC has coordinates 4, 3, 2, 7, and 10, 4. We're going to make a dilation of this to make another triangle that's 8 times larger. What will the new coordinates of the vertices be? Well, it's really simple. We're simply going to take all these coordinates of the original points and multiply them by 8. So our new triangle, A prime, B prime, C prime, is just going to be all the same numbers times 8. 4 times 8 is 32. 3 times 8 is 24. What are the coordinates for B prime and C prime? Well, B prime is at 16, 56, and C prime is at 80, 32. We can talk about the side lengths without graphing it as well. Here, if we're told the original lengths of the sides of a triangle, triangle ABC has 3 sides. Side AB is 5 inches, side BC is 7 inches, and side AC is 11. If we took this triangle and made one 5 times larger, performed a dilation to create a triangle that's the same shape but 5 times larger, what would be the lengths of the sides? Really simple. We're going to take the lengths of the sides of the original triangle and simply multiply by 5. The number that we're multiplying by is called the scale factor. So in this case, side A prime B prime, we do 5 times 5 and get 25. B prime C prime, 7 times 5 is 35. And A prime C prime, 11 times 5 is 55. Now we said dilations are when you make an object larger or smaller. What if we make the problem smaller? What if we take a triangle and make a smaller version of it? All the same rules still apply. Let's take a look at a simple problem. Like the first one, if triangle ABC has these coordinates, A at 12, 20, B at 8, 4, and C at 20, 16, what if we wanted to make a triangle that is 1/4 the size? What would the new coordinates be? Now, people will be tempted to say, oh, this is easy. If I want to make one that's basically 4 times smaller, they're thinking, I can just divide all these numbers by 4, and that will work. But I'm going to encourage you to say, we're not going to divide by 4, we're going to multiply by 1/4. And there's a really simple reason for that. Later in the year, when we talk about dilations and shapes being the same shape but different sizes, we'll have some formulas for talking about them. In those formulas, we can either have a formula using multiplying for when something gets larger, and a formula with dividing when a shape gets smaller, or instead of dividing by 4, we can think of it as multiplying by 1/4 and just have one formula. And we like to do it that way, and so we call that number, again, the scale factor. So in this case, we're going to take each of these numbers and we're going to multiply it by 1/4. 12 times 1/4 and 20 times 1/4. That'll be 3, 5. 8 times 1/4 and 4 times 1/4. That'll be 2, 1. 20 and 16, when we multiply by 1/4, become 5 and 4. The same thing works if we're told the lengths of the sides, not just the coordinates. Here I have a triangle. The side lengths are 18, 22, and 10. If I wanted to make a triangle that's 1/2 the size, what are the lengths of the new sides going to be? No problem. We're going to take the three lengths that we know and simply multiply by our scale factor, 1/2. 18 times 1/2 will give us 9 inches. 22 times 1/2 will give us 11 inches. And 10 times 1/2 will give us 5 inches. Now, just like the other transformations, we can get a picture of this by using a program, Geogebra. So if you go to geogebra.org, select geometry, and just like in the other assignments, we're going to create a grid in the background. So right-click, show axes, right-click, show grid, major grid lines. But this time we're just going to work in the first quadrant. So I'm going to just grab the graph and slide it down here. So we're only looking at numbers in the first quadrant. And we're going to draw our triangle. Next, we're going to draw our triangle by going to the polygon tool and clicking on the following points. How about 2, 2, and 4, 4, and maybe 2, 6. And then we got to go back to point A to complete our triangle. So now we have our triangle. I'm going to put labels in mine. You would not have to do that in yours, but it might make it easier for you to follow what we're doing here. So I've included the coordinates 2, 2, 4, 4, and 2, 6. And we want to perform a dilation on this triangle. We're going to take this triangle and make one 3 times larger. To do that, select the More option, and scroll all the way down, and the transformation tools are right near the bottom. And one of the tools is Dilate from Point. Now it says from point, so we're going to need to have a point as the center of our dilation. We're going to need to put a point at 0, 0. So we're going to scroll back up, select point, and click right at 0, 0. We could use other points, but in this class, our center of dilation is always going to be 0, 0. Now, scroll back down and select the tool Dilate from Point. And we're going to click once on our triangle, once on our point, and it'll ask us, what scale factor do you want to use? Well, we said we want to make one 3 times bigger, so we're going to put in 3 for the scale factor, and we should get a bigger triangle that's 3 times the size of the original triangle. If your screen is like mine, it may not fit. You may have to zoom out so you can see the whole thing. That's fine. I'm going to go back to the arrow tool and drag my graph back to where it all fits on the screen in one spot. If we need to find the coordinates of our new points, this should be relatively easy. Our new coordinates for A prime, B prime, and C prime. A prime is at 6, 6. B prime is at 12, 12, and C prime is at 6, 18. All we do is take the original coordinates and we multiply them all by 3. We can also take this new triangle and make it smaller. Before we do, I'm going to change the colors so it's a little easier to see my triangles. You do not have to do it, but it's relatively simple to do. I'm going to click on the triangle here, and I'm going to select color. I'm going to make the original triangle blue, and I'm going to make it dark so you can see that. And we'll do the same for the next triangle as well. Make it green and make it dark so you can see it. Now what I want to do is I want to take the green or larger triangle in this case and I want to make a small one. I want to go the other way. I can take this bigger triangle and I'm going to dilate it and create a triangle that's 1/6 the size. But we repeat the process. It's almost the exact same. We're going to select Dilate from Point, select the green triangle, click on the center of dilation, the origin, and to put in 1/6, we just type 1/6. It's 1 divided by 6, and we can create our new little miniature triangle here. It made it green. I'm going to change that color so we can see that it's a different triangle here. And then if we wanted the coordinates of our new smaller triangle, the 1/6 of the green one, which is also 1/2 of the blue one, we can simply multiply the coordinates of the green one by 1/6. Using GeoGebra, we can also zoom in and drag over and zoom in until we actually can see the coordinates and count them off. So I'd ask you, what are the coordinates for the red triangle? Well, you'll notice, by the way, A is now A double prime. It means we've performed 2 transformations on this point, and it's at 1, 1. B double prime, there we go, is now at 2, 2. It's B double prime, 2 apostrophes, because we performed 2 transformations on it. And C double prime is now at 1, comma 3. We also don't need a whole shape to perform a transformation. We could go back and perform a transformation simply on a point, on a dilation of a single point. So back, and I'm going to be starting over real fast here. Go back, geometry, show axes, show grid, major grid lines. Zoom in here, and I'm going to take the point tool. I'm going to put a point at 0, 0, and let's say we put a point at 4, comma 3. Point B at 4, comma 3. We can dilate just the coordinates of a single point. Again, under more tools, dilate from a point. I can select point B as the point I'm going to multiply, and point A is my center. And we're going to put in any scale factor we want. Say if we wanted to make our new triangle twice as large, put in the scale factor of 2. And we get point B prime, which would give us the new point B, which will now be at 8, comma 6. So, using GeoGebra or not using GeoGebra, you should be able to answer a question even if whether you have the picture or not. So I'm going to take the picture away and see if you can do this. If I graph a point at the coordinates 10, comma 18, and I performed a dilation with a scale factor 3 times larger than that, what would be the new coordinates for that point? For the point 10, comma 18, if I want to dilate it with a scale factor of 3, I would just multiply the numbers by 3. 10 times 3 would be 30, so our x-coordinate would be 30. 18 times 3 would be 54, so our new coordinates would be 30, comma 54. What if we had the point 10, comma 18, and I wanted to dilate it with a scale factor of 1/2? What would the new coordinates be? Well, if we start with the point 10, comma 18, we're simply going to multiply both numbers by half. We'll get 5, comma 9. You can use GeoGebra to do this, or figuring it out simply by multiplying by a scale factor is probably a significantly faster way to